All right, let's go through this handout here together. So let's start by looking at number 1. We'll just kind of go around the room. Hannah, what did you get for number 1?
I'm looking for my sheet.
Uh-oh.
Yes.
Okay, we'll come back to you.
Okay.
Oh, did you find it?
Oh, I did find it.
Okay.
I did not do number 1.
Okay. Marshall, what did you get? Nathaniel? It sounded threatening there.
Don't ask me.
You didn't do number 1, okay. Nina.
Number 1 was kind of hard for it, so I'll tell you.
Kate.
I really wish that I could tell you that I didn't.
Stop talking, please. Julie, what did you get for number 1?
Join the club.
Okay, -2 plus minus, okay. Okay.
Plus and minus 2i squared root 3.
Okay. And there should be one more solution there from the linear part.
So
X equals 2. So those are the 3 solutions. Underneath the radical is a 3. Yes, that's the case. McKenna, what did you get for number 2? Okay. Sierra?
Oh, I'm just doing number 1.
Did you do number 2? Okay. Sitong, did you get an answer for 2? Okay.
We're going to go all the way back to
Sophia. I'm sorry, that's not your name. Lexi.
Is it 1.5 negative 1.5?
Okay, so no, those are 2 of the answers. There's 2 more.
Oh, no, I'm not for that.
There's also 1.5i and negative 1.5i. Jack, did you get an answer for 3?
Yes.
What did you get for 3?
They're not right, but I got x negative 1 and square root of 2.
Okay, those are not correct. Do that.
I like the set.
Well, if I put like an x next to it, that's kind of confusing because we already have x equals.
I thought you were going to say that that's like too negative for you.
How about, okay, so still on 3, Christian. Okay. Matthias. Christina. Kathy. Okay. So I just want to say here, this is rather disappointing that we've gone through the entire class and we have, 2 problems that people have had, or 3 problems, I guess, that people have had answers for. It's going to make it pretty difficult to be able to do this on the test when you haven't done any of the homework. I'm just being real honest here. So let's do this. And go back to the beginning. How do you start any one of these problems? Anybody?
Look at the number of terms.
So, good. We need to start by factoring. And the first step in factoring is to look at the number of terms. Annuity is not here. You're welcome. Okay, so in the first one, how many terms do I have? 2. So the first thing I look for, is this a difference of 2 squares? No. Why do we know it's not a difference of 2 squares? Good. So Jack says because the degree on the x is 3. You can't have a difference of 2 squares with an odd degree monomial, right? Everybody's cool with that? Okay. So then we'll look, is it a sum or difference of 2 cubes?
Yes.
Yes.
Yes. So how can I rewrite x cubed as something to the third? It's just x to the third, right? How do I rewrite 8 as something to the third? 2. Because 2 times 2 times 2 is 8. So I'm going to then use my difference of 2 cubes factoring pattern. Okay. So this is like my A, and this is like my B. Okay, so what will I write first then? I'm going to write A, instead of A minus B, I'm going to write what? Anyone. Yep, so now I'm doing this. This is my factoring pattern. So instead of writing A minus B, what do I write? What is A? X. And what is B?
2.
So I'll write what?
X minus 2.
There you go. And then what am I going to write? Good. Plus 2x.
2x plus 2.
Or just 4. Everybody okay doing that? So we should take a quick glance through here and check to see if there's any more factoring we can do. Can I factor x minus 2 anymore? No. Why not? It's a degree 1, right? Can't factor degree 1s anymore. I mean, you could pull a common factor out or something, but like that doesn't matter for solving purposes. How about the x squared plus 2x plus 4? Can I factor that anymore? You cannot. Why? So we had mentioned this a couple of times now. The 3-term, the quadratic part that comes out of a sum or difference of 2 cubes is never factorable. Now, you could try to factor it, but are there 2 numbers that multiply to give us 4 and add to give us 2? No, there's not. So right away you could...
I was just answering the first question.
Okay. So we're done factoring. Everybody agree now?
Yes.
Yeah, I agree.
Okay. Once you've factored it, what do we do next?
You got to,
Eliminate the terms and find a common denominator.
No, there's no fraction here. I don't know what common denominator would be like.
go to the
You know,
2 term.
when you're doing up on the board, it's like you use 5 and 5.
Nope, we're not. There's no greatest common factors here. So if you look at these, it's easier than that.
Go to the 2 term.
We've already checked to see if everything was factorable. We've already finished that. We're done factoring it. We still need to solve, though. Okay? So what do I do to solve this? Great. So Jack says set each of the factors equal to 0. Why is it okay to do that? Because it equals 0. Can you do that if it doesn't equal 0?
No.
No. This is special for only equaling 0. You can do this. So now I can solve these as 2 separate problems. How do I solve x minus 2 equals 0?
You add 2.
Add 2. So that's one answer. How do I solve x squared plus 2x plus 4 equal to 0? I wouldn't want to isolate x squared because I have two kinds of x's here.
Maybe take away that 4 or square root maybe.
So Hannah's saying, why don't we use the quadratic formula on this? That is what you would want to do here, because this doesn't factor and we have two different kinds of x's. So the best way to solve, in fact, the only way to solve this quadratic is to use the quadratic formula. So who remembers the equation for the quadratic formula?
X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a.
That's correct.
Like 8th grade.
It's a good one to have memorized.
My teacher's telling me a song.
I don't know what to say.
Tell me a song.
All right. So the next thing that we'll do is we'll simplify the part inside the radical. So I have 4 minus 16. What's 4 minus 16?
Negative 12.
Good. So I have 2 plus or minus the square root of negative 12. How do I take the square root of a negative 12?
The I.
Very good. So I can replace the negative sign underneath the radical with an I outside the radical. And if you left this as your final answer, that would be okay. We can do a little bit more, though, because we can simplify the square root of 12.
Could do that. Leave it as our answer or no?
So, yes. So we notice the square root of 12 is the same. 12 is the same as 4 times 3, right?
Yeah.
So the square root of 12 is the square root of 4 times the square root of 3. And the square root of 3, or the square root of 4 is 2. So this is the answer that Julie quoted. In the back. Okay. And we can do even a bit better than this, though. Notice there is some reducing we can do. Everything is being multiplied by 2 in the numerator, and we can divide the denominator by 2. So I can simplify this down to that. But I would say any place after this would have been okay. All of those from that point on would have been fine for me. All right. Why did I? Oh, I did not mean to. Thank you, Jack.
Wait, you said the testing on this after break, correct?
Yes.
After break? No.
No, honey.
This is chapter 5. This is happening before break.
Yes.
Yes.
This is like final.
But we're just kind of continuing.
But you actually did say something about that. But like, you also did say it was like going to be before break, but then you did say something about finishing the chapter after break. But you said that we would have a test next.
So chapter 5 that we're working on right now, the test will be next week. After we finish chapter 5, we'll work on chapter 6 for the remainder of the year. Chapter 6, we're not having a final in this course. Chapter 6 will finish in second semester and test in second semester.
So chapter 6 will be on next semester's final?
Correct.
So that'll be our first grade.
Correct.
For this final hour, for the final for this hour, can we just leave?
I don't know the rule on that, to be honest with you. Okay, so let's look at 2 now. Everybody okay? Let's look at number 2. Lexi, you helped. You had some answer for this. What did you do first here?
I'm like 99% sure I did this completely wrong.
Okay. After seeing us do number 1, what would be the first thing we need to do here?
Divide the 16.
We'd want to start by factoring.
Yeah.
Okay?
That's what I meant.
So when we go to factor, we look first at the number of terms. How many 2 terms? 2 terms, okay. The first thing we check in the 2 terms, is this a difference of 2 squares?
No.
It is.
It is.
Well,
1681.
so 16 I can write as 4 squared. And x to the fourth I can write as x squared squared.
Oh, that's nice.
81 we can write as 9 squared. So if I apply my difference of two squares formula, we have this, right?
Yeah, now you just do both the zero, right?
Well, we should check to see if there's more factoring we can do.
Yeah, it's looking like.
Yes.
Yeah.
What can we still do? The 4x squared. Which factor can factor more? The first one or the second one? Not the second one. Just the first one. How does the first one factor? So it's a difference of two squares again, right? Do you see that? How does 4x squared minus 9 factor? Well, 2x minus 3 times 2x plus 3. Why can't we factor 4x squared plus 9, though? Because it's a sum of two squares. There is no sum of two squares factoring allowed. We can only factor differences of two squares. Is everybody okay with how we've gotten to here? If you're not, please speak up and we can talk about it some more.
I'm a little confused.
Okay, where did we lose you, Clayton?
So, I don't know why we went to the first one.
Okay, so
It's like the same thing. It's one plus one.
right, the difference of two squares has to be a squared minus b squared.
Okay.
There is no sum of two squares factoring pattern. That will never factor.
So if it's minus.
So you have to have a subtraction symbol to do a difference of two squares.
Okay. I'm back.
Okay. Now we can set each of these equal to 0 and solve. So to solve 2x minus 3 equal to 0, what do we do? Add 3 and divide by 2, right? There's the 1.5 that Lexi got. To solve 2x plus 3 equal to 0, what do we do?
You gotta subtract 3 and then divide by 2.
Good. That's the negative 1.5 that she quoted. Okay. To solve the 4x squared plus 9, what kind of an equation is this?
Okay.
Quadratic. What's going to be the best way to solve this quadratic equation? You could use the quadratic formula, but there's a faster way to do this one because we have only one kind of x. Notice we have just x squareds. We have no regular x's in this also. So I can just solve directly. I can subtract 9 from both sides, divide both sides by 4, and then square root both sides. So that's going to give me plus or minus the square root of negative 9 over 4. Right? I mean, I'm limited on how much space I have here because the other problem took so much space.
Taking up a lot of space here.
Yeah. I'm going to... It's plus or minus the square root of negative 9 over 4. Okay? Can we do more with that? How do I square root a negative? I get an I. That'll give me the square I times the square root of 9 over 4. How do I square root a fraction? Okay, so what's this? Good. So I have plus or minus 3 over 2i. So that's the 1.5i and the negative 1.5i that I quoted. Lexi, I'm guessing that you did this by just adding 81, dividing by 16, and then square rooting twice or something.
Yeah.
So you lost the imaginary solutions when you do it that way. That's why it's important that we factor in order to solve, because you will never find those imaginary solutions by doing that. Michael? Certainly. All right. So I'm just going to scroll down to a blank sheet, and I'm just going to write the problems in at this point because,
We're taking up a lot of space.
yeah. So 3. Okay. So, first step.
3 terms.
So we're going to factor. So we're going to look at the 3-term factoring. Good. Before I start factoring a 3-term, I need to check to see it's in the quadratic form. Is this in the quadratic form?
Yes.
Yes. Why? Because it's degree 4, degree 2, degree 0. Everybody's good with that? Okay. So what we'll do then is we'll make our substitution. So what should we set our y equal to?
Y x squared.
X squared. Always the variable from the middle term. So when I make that substitution, I have something that's expressly quadratic. So x squared squared becomes y squared, and then the 2x squared becomes 2y, right?
Yeah.
Okay, so since the leading coefficient on this quadratic is 1, I can do the short factoring. All I need to do is find the two numbers that multiply to give me negative 35 and add to give me negative 2.
Oh. 5 and negative 7.
Great, so I have y plus 5 and y minus 7. Everybody okay there? But we don't want to solve this over y, we want to solve over x. So let's put our x squareds back in. Everybody's okay there. Now what do we do?
You look for any more effect.
Okay, good. So let's see if we can factor any more. X squared plus 5. No, right? Because of the plus sign and the fact it's a degree 2. The only thing it could be is a difference of 2 squares, but it's not a difference. So we're done there. X squared minus 7.
The minus sign makes me think yes. 7 makes me think no.
Good. So it could be a difference of 2 squares. The first term is a something squared, and it's minus, but 7 isn't something squared. So we're done. Good. So we'll then just set each of these two equal to 0. How would I solve these quadratic equations?
Would you take it to the other side and square it, or would you just spend it the right way?
Yeah, I would solve this directly. So I would get the x by itself and then square root both sides. So we'll subtract 5 from both sides, and then we'll square root both sides. When I square root both sides, what do I get?
Would you do like the I5, square root of 5?
Get plus or minus. And because I'm square rooting a negative,
I square
the I comes out, and I have still the square root on there.
What if you put the 5 first? Okay.
Yeah, typically I like to write anything in front of the square root, so I can't accidentally think I have like
Okay.
the square root of 5i where the I is underneath the square root, because that's not what we mean.
Yeah, okay.
So usually that's the way I write them, and it's kind of the standard way to write it so there's not confusion over where the I is, whether it's under the square root or not under the square root.
Okay.
Let's do the same thing then for this one, right? So we'll add 7. We'll square root both sides. Can I simplify the square root of 7 at all?
No.
No, because 7 is a prime number. I know that I'm done. So those are my 4 answers. Plus minus I root 5 and plus minus root 7. Okay. What do you want to do first for number 4?
We got to factor by grouping.
Good. Since there's 4 terms, we'll try factor by grouping. Note here that the sign in between the two groups is already a plus sign, so I'm good to go there. From the first group, Sierra, what's the greatest common factor?
Greatest common factor is
X squared is correct. When you take the x squared out, what's left? Close.
X minus 5.
X minus 5. Something like that. I picked on Sierra because we were working on this together the other day. From the second group, what's the greatest common factor?
2.
4.
4.
2 is a common factor. It's not the greatest.
Not
Yeah.
DCF.
Yeah. So what's left after we take the 4 out?
X minus 5.
Okay. So far, so good. Now we look at the thing as a whole. What's the greatest common factor across the whole thing? X minus 5. Okay. And what's left? X squared plus 4. Okay.
Now you can just solve it.
Well, we should check to see if we can factor anymore.
You could.
Oh wait, no.
No, it's not a difference.
No,
So,
not this time.
yep. So we're done. We can go to solving now, or done with factoring anyways. So x minus 5.
Wait, hold on.
Yeah, I'm holding.
Why did x squared? Oh wait, no, I'm sorry.
Okay. Sounds like you sorted out whatever that was. All right, fair enough. To solve the x minus 5, what do you do? Add 5. And the x squared minus, or the x squared plus 4?
Minus 4.
Good. So I subtract 4 from both sides, square root both sides. So I get x equals plus or minus.
I square root. I2. Or I2.
Yeah, let's call it 2i.
2i.
When there's not a square root, we'll prefer to write the I at the end like it's a variable or whatever. Even though it's not a variable, but kind of we treat it like one when we manipulate it algebraically. Okay, so that's that one.
Factor by grouping here.
Good. So again, we have 4 terms, so let's do factor by grouping. What do we have to be careful about in this one, though? The negative that's in the middle, right? How do we fix that subtraction in the middle?
I don't know.
I'll just make it plus a negative. Easiest possible fix, right?
That's very simple.
Very simple. All right, what can we take from the first group?
X cubed
Good. And that leaves us with?
x squared plus
Good. And then from the second group, what can we take?
negative.
-1, right?
Solid.
And what do we get after that?
X squared plus 3 is 4.
Because we're dividing, right? Question on what we did there? I heard somebody ask something. Christina? So notice in the second parenthesis, I have each of the terms are negative. So I'm going to factor that negative sign out, and I'll write it as like a -1. Does that make sense? Okay. All right. Now what?
We still do greatest common factor.
Mm-hmm.
It's x squared plus 4.
Good. And when we factor that off, what's left?
X cubed minus 1.
Okay. So far, so good? Okay. Is there more factoring we can do?
Yeah.
Okay. Can I factor the x squared plus 4 anymore?
No. But
No.
the difference of 2 cubes.
Yes. The x squared minus 3 is a difference of 2 cubes. And hopefully it's relatively easy to see that I can just write that as x cubed minus 1 cubed, right? So this is like my A, and this is like my B. So how do I write the factored form then for that? X minus 1.
X squared plus.
That's correct. Is everybody okay with how I factored the x cubed minus 1? Okay, so I would give you those patterns on the test or whatever, so you don't have to memorize those,
Like
but
the 2 cubes.
yep. All right. Oops. Somehow that turned into a minus halfway through the problem. That's not right. Now everything is factored completely, and we can set each of these equal to 0 and solve. Christian? Certainly. We already know what x squared plus 4 equal to 0 is, right? Because we just solved that in the previous problem.
Yeah, wasn't it like x equals plus minus 2y?
Yep. So I'm not going to do that work again. I'm just going
Not
to,
necessary.
yeah, we just did it, right?
Time saver.
It's on our paper already. This one, how do I solve this?
Add 1.
Good. And then the last equation, how am I going to solve that? Quadratic formula is correct. Notice because I have two kinds of x's here, x squareds and x's, probably going to need to use the quadratic formula, or else I could just factor, I would have factored it more by hand, right? Because we checked everything to see if we could factor it already. So, okay. So what's our value for b? 1. So negative b plus or minus square root b squared minus 4. What's our value for a?
1.
And then c is
1.
all over 2 times a. So when I simplify that down, I have negative 3. Okay, can I do any more with that? What can I still do? Excellent. So the last thing I would need to do is get rid of the negative underneath the square root. And I just trade out the negative under for an I outside. And that's as good as we can do on that. Is this feeling a little bit more doable?
Yes.
Hopefully, right? All right. Let's do one more together, and then I'm going to give you guys a few minutes and try one of these or two of these on our own, okay? I'm only doing this because one more right now, because this is, I think, the worst one on here.
Numero 6.
Yeah, I think this turned out to be the most work anyways.
How many answers do we have?
This one has 6 solutions.
What?
It's a large amount of solutions.
It's possible you miss some plus or minuses.
How do you know how many solutions?
Oh, that's an excellent question. This is actually something we'll talk about in depth in chapter 6. But the short answer is if you're counting repeated solutions and imaginary solutions, the degree of the polynomial will give you the number of solutions.
Oh yeah, that totally makes sense.
So since this is Sierra, since this is a degree 6 polynomial,
Yes.
I'm expecting 6 solutions.
But it's not like that for everyone.
It is like that for everyone, depending on how you're counting them.
Well, for number 1, we got 2 solutions.
We did not have 2 solutions because we had the plus or minus.
Oh, silly.
So there is 3 there. There's 1,
Question.
2, 3.
I understand.
You guys call it sleeping.
Okay.
Yes.
All right. So
This is looking like the classic quadratic form.
yeah, so this is a degree, or it has 3 terms. So we'll check to see if it's in the quadratic form. Is
It
it?
is.
So degree 6, degree 3, degree 0, sure is. Since the leading coefficient is not 1, we know we're going to have to do the long factor on this. So I'm going to need to find 2 numbers that multiply to give me the first and the last, and add to give me the middle. What did that give me? 1728. So what are those two numbers? Let me save you guys the hassle. It's negative 64 and positive 27, because we got to get negative 37. So I did that by exhaustion. Actually, it didn't take me by exhaustion. I wouldn't make it this big of. I would not.
Oh, okay. I thought he says I would make it this hard. I was like, what?
How did I get negative 64? Yeah. So you want to, for me to tell you how I did this, do you really want to, when I look at this and how I'm able to do this in my head?
Yeah. No, I just know. How did you get negative 64 from like
Still, yeah.
So I'm looking here. I see I have 8 is 2 cubed. 216 is 6 cubed. So that means I have a 2 cubed and a 3 cubed. So I'm just kind of moving around the 2's and the 3's, because I know my, whatever the two numbers are, I have 6 2's and 3 3's to make them. So the first one I tried was just all the 2's together and all the 3's together, and that was it, actually what I needed, was 64 and 27. So that's kind of what I do when I look at these, is I look at kind of the prime factorization of the two numbers I'm multiplying together, because that really kind of, I don't have to check everything then, because there's a lot of numbers from 1 to 1,728 to check, right? Getting all the way to 27 was going to take some minutes.
Yeah.
All right. So what do I do with these two numbers then? Because I can't go straight to my solution with them. Oh my goodness. We forgot to make our substitution. What should y be?
X cubed.
Good. Okay. Now I'm going to use those two numbers to rewrite negative 37y as negative 64y plus 27y. And then make my two groups.
So you said you're not gonna do this one like one this hard on the test.
Well, just the numbers getting this big.
Yeah, maybe not like a triple digit.
Yeah, that's probably a bit too much.
Yeah, I agree.
All right, so the greatest common factor from the first group is 8y. The greatest common factor from the second group is 27. And then I look for one more greatest common factor, which would be y minus 8. And then I put my x's back in. You probably did not do this in Algebra 1. We did this earlier when we factored quadratics this year.
No, I'm not like Algebra 1. It's like, I just remember like taking it, putting it like together.
You might have. It's possible, Lexi, depending on your Algebra 1 class. You might have factored quadratics there.
I missed 1 and 2 step equations. Those were the best.
Okay. You did do that?
Yeah.
Okay. Good. That's good. You had a good Algebra 1 teacher then.
I had no idea what he was doing.
Okay. Well, you had a good Algebra 1 curriculum then, because that's something that you decidedly should do that a lot of times doesn't get done. All right. What do we still need to check? Shh. Hey, let's refocus here, please. What do we still need to check? If any of these factor, right? X cubed minus 8. Yes?
Yeah. No. Oh, yeah. It's 2.
It's a difference of 2 cubes. In fact, look at problem number 1. It's the exact same problem as number 1, right? Yeah. So all I'm going to do here is I'm going to write that and write the answers that we got from number 1.
Wait, what's this?
That's me saying number 1. Yeah, whatever you want to call that. In my day, it was a pound sign when you used a telephone.
The youth calls it a hash.
Okay. So Jack, all I'm doing is I observe that x cubed minus 8 is number 1 on this assignment.
Oh, okay.
So I'm just using my answer from number 1. I'm not showing any work because I already solved that problem. Is everybody okay with that? You're welcome to do that on any homework assignment or whatever. You can skip showing work. If you're like, yo, I've already done this problem. That's fine. All right. The next one is, can I factor 8x cubed plus 27?
No.
Yes. That's a sum of 2 cubes.
Dang it.
So how can I rewrite 8x cubed as something cubed?
Wait, do you think you have to memorize the sum of two cubes formula?
No.
You do not.
Oh, cool.
No. No. Oh,
Yes. Sure. So there's that. We factored it. Then I'm going to set each of these pieces equal to 0. I still have one more though, right? How am I going to solve 4x squared minus 6x plus 9? The quadratic formula. Very good. So, what do we got here? 36 minus 72, which is negative 36. And how do I simplify that? Yeah, did I do that right? No, that's not right. My apologies. 4 times 4 is not 8. Is what I did in my head. It's, yeah. So this is, what did I get here? 16, I didn't write it down. 149? 144, yes, of course. 12 times 12. Okay, so 144 minus 36 is, or I'm sorry, 36 minus 144 is negative 108. Everybody's okay there. So what can I do with that still? How about do that, right? Okay. 108. Does that look familiar to anybody? I can probably write that as what? If I want to simplify it some more. How about 36 times 3? Why would I choose those two numbers?
Because 36
times 3 is 18.
has a square root.
Carry the 1.
Because 36 has a square root. And then notice that everything in the numerator and denominator is divisible by 2.
Oh, yeah.
So I can reduce that, and there's my best answer. You guys try to do 8 by yourself right now.
Ooh.
If you get...
Scares me.
I'll give you a hint to start this. Look for a greatest common factor before you even do anything else.
I always have trouble starting this problem. Are you gonna show us how to do it after?
Mm-hmm.
Okay.
So if you make a mess of it, we'll clean it up. Oh, why are we doing 8? Anyways, whatever.
What were we supposed to?
We skipped 7.
Oh.
That's okay.
It's to the floor.
So does your hand still
Yeah.
fly?
Yes. Yeah, I was looking at 8 also.
I was just staring at that earlier, marveling at it. Now it's dead.
That's okay. Sophia will fix it on Monday.
Which Sophia?
Duabo. Yeah, that too. Oh yeah, I have Olivia, not Sophia.
That's okay. I know what you meant.
Yeah. Somebody.
Somebody named something. Somebody with a name will fix it.
The first one in the family that I meet is the one whose every sibling is then gets called that
That
name.
is the most painful thing.
At least for the gender. If it's an opposite, if it's a different gender, I can usually get those straight. But like, there's like 4 brothers. The first brother whose name I learn, all the brothers get called that for the rest of the time. It's a bad habit, but it's like I do that. I've done that to like Jacob Anderson, like the entire year. I call him Adam at least once a week, and I do that with James. I call him Jonathan like at least once a week. It's bad.
Wait, who's James?
Chabot.
Oh, wait, he's a brother. Jonathan?
Jonathan's his older brother.
I didn't know that.
He graduated like before even James was in high school.
Back in middle school, you used to call my
How long
brother's
have you
name.
been teaching, Mr. Blue?
Oh boy. I think this might be the 10th year here, maybe the 11th.
Oh, and you used to, I know this, you taught somewhere, and you coached cross country and track. I saw it on the article on Morgan.
Yeah, you did used to.
I read that. I
I-
saw your face.
We're
when I
gonna
read
do
it.
track.
I did used to coach track and cross country. It got to be too much. So like I'm doing grad school, and now I have a new baby, and I have a new wife. Like there's yeah, we got married like not even a year ago, or just over a year ago. Excuse me. So just over a year ago. So it's like there's some stuff in my life had to go. That was
Yeah, I saw your face on the Twitter, so I got on it and read it.
Mr. Cooler, wait, so you should.
oh I do not have the time for that anymore. I am sorry.
Wait, did she a scoop with?
No, I
Coach Thank God. He was crazy.
Did you learn cross country in high school?
And in college, yeah.
Ooh, what college?
I went to Albion.
So did my parents. Both of them. Let's go. Go friends.
That's cool.
Yeah, it was a lot of fun.
Sounds like a lot of fun.
Yeah. You get the first question so much.
It's like an hour, like kind of by hand, right? Albion?
Yeah, it's east, or I'm sorry, west of Ann Arbor still. But
I was like way up in the.
oh, you're thinking maybe of like Alpena or something is over there.
I don't know, sounds
All right, so this should have been your first step.
See that? Okay.
And then what do you see?
That is 4.
Isn't that exactly problem number 2?
Yeah.
That's it. That's what I would have. That's what I did. It's from there. It's exactly the same as number 2, right? 16 to the 4th minus 81 is exactly problem number 2.
Yes.
So you do it the exact same way. I don't know what time this class is.
I think it ends at 40. Because you have 5 minutes of passing time and an hour of class.
Cool. I didn't even know how long classes were, to be honest with you. I've just been like,
5 minutes short of this one.
fair enough.
Yeah.
All right.
I think.
Is everybody happy with 8 then? That's enough information about what to do since we already did 2. Do 7.
So, When it's in quadratic form, what do you do from there?
You do the quadratic
Well, you try to factor like a quadratic, right?
It wasn't as much of a song as it was a tune. Wait.
All right. Hey, everybody.
Hey.
Try do 7.
So.
Try do 7.
I cannot believe you just did that.
On Tuesday, I'm going to expect when we go through 7, 9, and 10, when I call on people, you have legit answers.
Wait, I'm so confused on what to do for the first.
I'm calling on every single one of you and having you say your answer for 7, 9, and 10.
We have to be number 9.
Yeah, 7, 9, and 10.
Okay, I did not know. Here you go.
So notice on number 8, Matthias, that where the first thing I did was factor something out.
Yeah.
Try doing that on number 9 and seeing if that helps. 9 is factorable.
Oh, I know 7.
7 is factorable.
Really?
Yeah.
Oh, hold on. Got this. I don't got it. It has to multiply to negative 60 and add to 19, right?
No. Has to multiply to negative 120.
Wait, for number 7?
Yes, because you have to do 2 times negative 60.
Straight into quadratic formula. So that's what I did.
Well, you're going to miss some solutions.
So no.
So no.
Okay.
So,
Erase.
so what would you do right away from here? Factor, right? But if let's say I didn't know I could factor that, what would I do? Let y equal x. Okay. And then from there.
Wait, 7, 8.
So I need to find those 2 numbers to start. That multiply to give me negative 120 and add to give me 19.
So you do 2 because it's the first.
Because it's the leading coefficient times the constant term. Now we always do that, Clayton,
Yeah,
but when the leading coefficient is 1, it doesn't really do anything.
You're trying to find
Multiplies to give me negative 120,
an
adds to give me 19.
See, that's a multi.
Okay.
I'm thinking it's going to be like 13 and 6.
13 is unlikely since neither 2 or 60 contain a 13.
14.
They don't contain a 7. 7 doesn't divide either of those. 12 is possible.
12 plus 10 does not, unfortunately, equal 19.
It does not. And then one of them is going to have to be negative and one's going to have to be positive, right?
True.
I'm thinking a wild card. 6.
So you do 6 and 20.
No.
Should they be getting closer together or further apart?
I'm thinking it's going to be like 20 something and something. You said I want to go to
How can
negative.
you figure this out on a calculator?
24.
Exhaustion.
So like,
You just keep dividing things by 120.
that's so like annoying. Like, there needs to be a
25.
program on your calculator for that.
Okay.
No.
How? Okay.
22.
So hold on. So 6. You said 6 and 20.
One of them's negative, probably. Okay, so
Right.
25 and negative 6. But no.
Okay, you're going so 6 and 20 was kind of close, right?
9 and
So you're manipulating the wrong one.
I am.
So let's pick 6. Like instead of 6, let's pick 5. What is the other number that, or what do you get when you do 120 divided by 5?
14.
Or 24?
24.
I just saw the first letter 4.
So 24 times 5, so negative
Negative
5
5.
times 24.
Okay, but yes.
Yes.
Took a while, but it works.
So you just have to
Divide
like screaming numbers until you figure out.
Yeah.
Because like
This
there's no program for that.
that is the hard part. I mean, there is, but it's like not a program that like you can do by hand.
That's so annoying. Like, I wish I could.
I'm gonna make a calculator that does that.
Well, I mean, they do. Marshall's calculator does this.
Marshall, you lucky duck. You lucky dog.
But this is like not an easy program or problem even for the calculator to do because it's doing it by exhaustion also. Yeah.
So it might take a minute.
The calculator gets tired.
Well, no, it's just checking everything until it finds the what works. When I say exhaustion, it means just like check everything.
You do it in 20 seconds.
Yeah, I know. Yeah. So I'm going to leave this here. You guys will finish this one.